We are now doing quiz 1, written by Mariya, Professor Mariya, for linear algebra course. And just wanted to let you guys know that eventually I will post typed version of the question somewhere on the link or whatever, so that people have a chance to look at it before they look at my solution video. Or if you like, you can just freeze the first, as soon as I mention the question, just stop the video and then try to figure it out on your own. And then, and then if you need to check for the solutions, then you can just resume the video and then see what I do, and hopefully that's right. But anyways, so let's just dive in right away. I would like to point at two things though. If you have Mariya, I don't know about the other professors, I'm pretty sure they have similar standards, but if you mess up with, nothing major, right? It's not like you forgot how to formulate the equations or follow the proper steps. If you just make stupid mistakes with, just additions or subtractions, that may cost you dearly, right? So try to make sure that, you check your answers. I finished like 30 minutes before the quiz was done. But I was like, well, I got it right, and I'm pretty sure I'll get most of the marks anyway, even if I made a stupid mistake and left, right? My professor made it very publicly clear that I should not do that again. So, a bit of a, dick move if you ask me, but no, whatever. I got it wrong, so she's not wrong. So I'll have to be a little more attentive. Fair enough. And needless to say, I didn't get 100. I should have, though. It's a shame, but whatever. Life goes on. So that's one thing you need to know, because if you make stupid mistakes like that, let's say first question, for example, this one is gonna be out of 20 points. If you make dumb mistakes, depending on where you made it to, right? You could lose like 10 points out of 20, right? Unfortunately, I got everything else right, so my grade didn't suffer as much. But I've heard some other more tragic stories, so let's be a little bit more attentive from now on. And yeah, but apart from that, in terms of difficulty level, not at all. It wasn't hard at all. Some of them actually were just direct copies from other questions. So anyways, enough rambling. Let's get the questions out of the way, okay? So this is the first question. Simple stuff. Unlike the other counterpart, we don't get to choose Gauss's elimination or Gauss's Jordan elimination, right? It specifically said Gauss's Jordan and elimination, which means we have to put in reduced form. So we have this linear equation. I've already took the liberty of putting it into a matrix format. And so basically what we are gonna do is let's try to look for a simple number. So I want this to be 1 probably, right? Because it's a smaller and is a number closest to 1. At the same time, I don't want to do division just quite yet. Simply because if that's the case, then this will become fraction, this becomes fraction, then you subtract fraction. Do not want fraction. You may need fraction, but let's hold up to the very last one. So I'm just going to directly eliminate all other competitors without reducing it right away, right? So let's go ahead and do that, right? So it's if anyone's wondering about the creaking noise, I'm doing this in a garage. I won't get into more details as to why, but I'm just kidding. But anyways, so row 1 stays the same because that's what we're going to use to eliminate the other guys. So let's see, it's 4, so it's going to be negative 2r1 plus r2 will give me new r2. So that's going to be 0, negative 2, add together, that's negative 4, yeah, and then the negative 2 times negative 1 is 2. 2 plus negative 2 is 0. And then that's going to be negative 12. Yes. Okay. And then so I want this to be 0. So that's going to be 2 times 4, right? So negative 4 R1 plus R3 gives me R3. That's going to be 0. And that's going to be negative 4, so that's going to be negative 3 plus 4, 8, negative 24. right? Negative 6 times 4 is negative 24 plus 0, so that's that. Okay, good. So that's that. Okay. Yeah, so these are all gone. I wouldn't really bother reducing it just yet. Let's work on... See, 3 seems closer to 1. So some people might think, oh, let's just make that into 1 and eliminate this guy. But pay attention to what the details is. There's 4 and there's 12. There's 3, 8, 24, right? So if I try to divide this so that negative 3 becomes 1, we're going to have a fraction problem, right? Don't want that. This one, though, is interesting. It's 4 and negative 12. So, you know, we can evenly divide this, right? So that's what I would do. So... for people who haven't seen the other quiz video solutions, I will make sure when I do the next section, 1.5, 1.6, and possibly 1.8, I will make sure I do it on a bigger board at school. Right now, I'm just trying to get this over with, so, you know, this small board will do for now. So, next one's going to be, so everything is going to be the same except the second row, which is going to be reduced. So, it's going to be negative, no, let's just make it 1. So, 1, 0. 3, 6, 0, negative 3, 8, negative 24. You don't need this line, I just put it because that way I know these are the coefficient numbers, right? So all I did here was I got the second row divided by 4 negative, right? Because it was negative 4, so I need to do negative to get a positive number. So yeah, so that's all I did. So negative 1, 4 are 2. Yeah, okay, good. So that's that. What else was I going to... Oh yeah, so that's that. So now I have the leading coefficient here. I'm going to use this guy to get rid of this competitor as well as this guy, right? So that's going to be an interesting... So row 2 stays the same because that's what I'm using to eliminate the other competitors. Let's look at this one first. 0 and 0. Right? So how do I use 1 to get rid of negative 3? I just row 2 times 3. That will be 3 plus row 3 gives me the new row 3. So if that happens, that's going to be 0 obviously. 0 times whatever is 0 plus 8, so that's going to be still 8. And 3 is going to be 9. Okay, so that's going to be negative 15. Right? So that's 9. Yeah. 24 minus 9 is 15. Yeah, so negative 15. Good. So how do I get rid of the first one? It's going to be 1, 1. So 1 to 1 ratio. So I'm just going to make it as negative so that it can cancel each other out. So it's going to be negative R2. Oh no. R2 plus R1 gives me R1. So if that's the case, then I'm going to have 2 stays the same. 1 will be cancelled out. 0 times negative 2 is 0, so it doesn't really affect anything. 6 R2, so negative 3, 6, that's going to be 3. Okay, so that's the, yeah, pretty sure that's right. So, and then what I do after, let's see, so I have this one, 8 is, can we simplify the 8? Yeah, we can use the 8 to eliminate this guy, right? This is where it gets tricky, because now like there's no way around it. We need to get the fractions involved. So, is that right? Okay, you know what? Okay, let's... So, oh no. So it's the second row, not making any changes. I'm actually thinking, now that I think about it, this may have been a smarter play. Rather than trying to reduce this right now, because we don't really have to, right? We just need, our goal is to just get rid of the 1. So what we could do, can't write the first row yet because that hasn't been eliminated. So in order to get rid of 1, I might just do this, right? I could just do 1 over 8 minus times R3. So that becomes, you know, this becomes negative 1, and if you add that, that becomes 0, right? Plus R1 gives me R1, right? So if that's the case, 0, there's nothing on zeros. This one will be 0. This is where it gets tricky, because I'm going to have 15 divided by 8 negative plus 3. The reason why I put right away is like I have to have a base of 8, right? In order to do addition. So 8 times 3 is 24, right? So this whole thing is technically 3, as it implies, right? So if that's the case, please give me a nice number. I highly doubt it though. This is gonna be 9 over 8. Ain't too bad. Yeah, but it's not. Yeah, okay. So that's gonna be 9 over 8. Okay. Alright, yeah, so that's that. And then basically what we are going to do afterwards, is this, oh no, we're not quite there yet. Remember, it has to be Gauss-Jordan elimination, right? Which means we have to make sure this is reduced as much as possible. So, now we get to play around here. This is a little distracting, so I'll get rid of that. Do we have room? Yes, we totally do. So if you do this, so I'm gonna have this, I'm gonna divide it by half so that 2 becomes 1. The fraction is going to be not great. 9 divided by 16, right? Because you know, dividing by 2, right? So 0, 1, 0, 3. This guy still stays as a happy camper. This one, I don't want 8, I want 1. So that's going to be 0, 0, 1. And that's going to be negative 15 over 8. So let's describe what we did. We just did half of R1 is a new R1. And this, for R3, we did 1 over 8 is a new R3. So this is what I would get, right? And what was I going to do? Okay, so, yeah, so that's, you guys see? Yeah, you guys can see. Okay, so yeah, so that, so this would be my solution, my reduced form, right? Then now we have to talk about the solution, which actually is pretty easy, because as you can see, these are all unique solutions, right? And I'll tell you why. Because there's x value, which equals to very specific value, y equals to that specific value, z equals this specific value. So there's no infinite solutions or inconsistent solution. There is only one unique solution, which happens to be these three, right? So let's rewrite. We don't even have to rewrite it, really. We could just say x, y, z, right? X, y, z, and the x happens to be 9 over 16, and y happens to be 3, and z happens to be negative 15 over 8. Okay? So, remember what I was saying about, how we should check the answers, especially when we have time. I reckon most people who know what they're doing will have extra time, right? Because we're not wasting time trying to figure out how to do this. Like, we already know. The question is how fast can we get it done, right? So, if you have time, just you don't have to check all the way, but give some checks so that so that you can kind of tell if you're on the right track or not, right? So I'm gonna look at the 2x plus y minus z. This just happens to be the question, just the first linear equation, right? So I'm gonna plug this in. I'll plug this in, and then this better give me 6. If it doesn't, then we did something wrong. So it's gonna be 2, 9 over 16. Plus 3 and minus negative 15 over 8. The numbers are a little too chaotic for my taste, but hopefully this turns out to be right. Hopefully. That's 16, not, yeah. So if we do that, that's going to be 9 over 8 plus 3. Oh, that looks like a good sign. Please, please, please. So that's going to add 15 over 8 gives me 6. I really hope it does. Oh no, it may not. Oh no, it might. So 9 plus 15 is 24 over 8. Yes. Plus 3. And 24 divided by 3 is Oh. You guys can't see. Okay, so let's drag it up there. So 9 over 8 plus 15 over 8 is going to be 24 over 8 plus 3 equals 6. 24 over 8 is 3 plus 3 equals 6. So not absolute guarantee, because technically if you want 100% guarantee, we should test every linear equations. In this question we have 3, right? Because we have 3 by 3 matrix. But this seems like a good, this is a pretty good assurance to us that, especially if you don't have that much time, or if we're not that, if we're not that attentive about this, like, good track, that's what I said, right? So that is 1. And this is the part where I lost my marks, because I wasn't paying close attention to the numbers, so made an early mistake, and I don't know how it was graded, but I imagine like half of the mark at least was just, do you have the correct answer or not, right? So it's a shame, because I did everything else right. I'm just whining and complaining. Let's move on. We're not here for my drama. Number 2, determine the value for A in which the system has no solution, one solution. So this is a situation where you're going to have a matrix, and in reduced form you're going to have some kind of algebra expression, and then we're trying to see, well, when A or X or whatever equals to some number, it's going to be inconsistent, or it's going to have infinite solution, or it's going to have unique solutions, right? Or unique solution. It may be just one, right? Usually with algebra though, I doubt it, right? Because the whole point is to cover a wide range of possible numbers, right? So if it's just unique solution, I mean, it's a fair game as far as I'm concerned, but kind of ruins the question. So anyways, so the equation we are given is actually 2x plus 3y equals to 0. And then you have 6x plus a square y equals to a plus 3. So, before we could, some people might have said, oh, let's just jump into this right away, right? We don't want to do that yet. We want to reduce it first so that it's truly 0 equals 0. Like, let's say this was 0 and 0, but that's not the case because we still have the 6 to deal with, right? So let's reduce it first, which means matrices. It's not a hard matrix to reduce, so let's not sweat over the little details, right? So I want to get rid of 6, so that's gonna be 2, 3, 0, because I'm going 2 times 3 negative, right? So that's gonna be negative 3 times R1 plus R2 gives me R2. So if that's the case, that's gone. Negative 9, so it's gonna be a square y minus, oh no, sorry, my bad. You don't put y. We only put the coefficients, right? So that's going to be minus 9, right? Because negative 3 times 3 is 9, so we subtract that. And then 0 times anything is 0, so it's still going to be 8 plus 3, 0. Okay? Now, we could reduce this further down to 1 and 3 over 2 and 0, right? But we don't really care, because the second rule determines whether you're going to have infinite solution or unique solution and stuff like that. So, yeah, so let's just focus on this one, because it's 0, so these two, we are only looking at these two, right? Because these things don't really affect this guy, right? I mean, if you had 0, 0, and 1 here, I don't care what it says here, like you're going to have inconsistency, right? So, let's focus on this one. So my strategy is that, I'm going to just put it like, actually, we know these numbers, right? So let's actually just erase that. Start from the beginning. Or like, I don't mean like beginning of the question, but like start from the fresh space. Because we're minus 9, a plus 3. So if we look at it here, so we have 3 possibilities, right? So if it's infinite solution, 0 equals 0. If it's if it is the inconsistent solution, I don't like putting 0 equals 1 because like you could get that around and say, oh, this is 1, this is 0. You know, inconsistent. No, if this is 1 and if it's 0, then we do have a solution. It's called trivia solution, right? X, you know, so Z happens to be 0, right? So that's not inconsistent. That still works. That's actually a unique solution, right? So you have to be careful, right? So instead of writing this, this is what I would recommend, just to shred the benefit of, shred all the down. 0x plus 0y equals 0. Why didn't I put z? Because we don't have z. This is a 3 by 3 matrix, yes, but unknown variables are only 2, right? X and y, right? So we don't put z because it doesn't exist there. But anyways, so, no. In order to do that, so I would just say equals 2, or you could just say they don't equal to 0. That works too, right? So this is inconsistent, so no solution. This is infinite solution. And then anything that is not infinite solution or no solution must be unique solution, right? There's no other alternative, as long as we're using the real numbers, right? So anyway, so yeah, so let's go ahead and do that. So let's try to make both of them 0. See if it's possible, right? So when would this left side become 0? Well, let's factor this out. Right? I mean, if you look at the format, this pretty much screams out, please factor me. Please factor me. If you don't, you are insert swear word, right? So so if I have that, it's going to be a equals 2 plus or minus 3, right? And then this is going to be a equals 2 minus 3 only, because if you put 3 here, 3 plus 3 is 9, so it's not 0, right? Okay, so left side, you need to be plus or minus 3 to be 0. Right side, you have to have negative 3 to be 0. Okay, so let's get the obvious out of the way. When is 0 equals 0? If you use negative 3, and if you use negative 3, if you put negative 3 here, 0. If you put negative 3 here, 0. So it equals 0 equals 0. So 0 equals 0 works if a equals to negative 3. Beautiful. What about 3? Okay, so if I put 3 here, the left side is going to be 0. Just like 0 here, right? But if I put if I put 3 here, 3 plus 3 is 9. So this actually becomes 0 equals to 9. Right? So 0 equals to 9, right? That is inconsistent. No solution, as we said. So when does that happen? A equals to 3. And that's all there is. Now, because we already established all possible solutions for infinite solution and no solution, right? Anything apart from those possibilities must be the unique solution. So that's what you would write, right? So oh, okay. I thought she said this was a mistake somewhere, but no. Yeah, this is perfect. So yeah, that's all you do. So you say this is the infinite solution. Too lazy to write. This is the no solution, or inconsistent solution, or whatever. And then anything that does not equal to positive or negative 3, it must be unique solution. And that's all there is for this question, right? Yeah, that's all I would say. Oh yeah, one more thing. You may have noticed that I've been using row instead of line, right? So whenever I do any kind of elimination, like instead of doing L1 plus L2 or something, I'm using R1 plus R2, right? So that's something that I've been noted. I didn't lose marks for that, fortunately, but my prof has, how should I say this, very gently recommended me that R is more of a proper format. I'll let you interpret the sarcasm. It's not my place to say. Yeah, but anyways, yeah, so try to use rows, not lines. So my mistake, but it's the same principle, right? It's just use a different notations. That's all that is, right? So number 3, simplify assuming the ABC. Oh, okay, so this, okay, it wasn't exactly the same, but come on, like it was pretty close enough, right? So you have this equation. You should have remembered from 1.4, right? So we have a question like B, A, inverse inverse okay. So yeah, so 3 inverses in case if my writing sucks, but yeah, so we have this equation, and then we're trying to see, well, let's simplify it as much as we can based on what we learned about inverse, right? So that's pretty simple, we learned about it already, right? So if it's inverse and there's multiple players inside, then we're just gonna do, switch to rows. It's gonna be A minus, actually I'm gonna make that a little bigger so that you guys can see it. So it's going to be A minus A inverse to the power of -1, B to the power of 1, and that's going to also flip too because it's inverse, right? So it's going to be B minus 1 minus 1, C minus 1, A. So again, this switches, C minus 1 minus 1, A minus 1. So we're gonna have that, right? Okay, so inverse of an inverse, so that cancels out the inverse, so you're gonna have A, B, and then B, and we're not canceling things out here. So B inverse stays the same, inverse of an inverse, so that becomes B, and inverse of C, and then this is gonna be inverse of an inverse of C, so C, and then you're gonna have, yeah, then you're gonna have A inverse, right? Okay, good. So that's that. So, first of all, this is the thing that I like to point out. Just because you have A and A inverse here, doesn't mean you can just put them like reoriented so that they're right next to each other and say, oh, they all cancel out to 1. I mean, they do, but that's not what you're supposed to be doing, because with multiplication, order matters, right? So, because of that, we're gonna cancel out the ones that are right next to each other first. So, these two are right next to each other, they're inverse of each other, right? So that's going to be A, that's going to be, not 1, be careful, it's identity matrix. It's the same thing, but, And then this is going to be 1, no, see, I'm doing this again, identity. So yeah, so that's that. Okay, alright. Now people are gonna freak out. But that's okay. Yeah. Okay. Do you need this soon?
Yeah.
Okay.
Can you delete that part?
No. Oh yeah, I'll deal with it. Right? But can let me finish this first and now I'll let you use it, okay?
Okay. Sorry for interrupting.
You don't have to be polite because people are watching.
Ha ha ha.
And the truth comes out.
That
Okay. Alright. Okay, sorry about the interruption, but A, I, and A inverse, right? So, here's the thing though, this is, I think, where people got a little bit thrown off. Identity matrix, so, like, can I just technically get rid of it? Because I want A and A inverse A to be right next to each other. Yes, but be careful how you say it, right? So, for example, like, I went a little extreme, but technically you could say A times I is the same thing as A, right? Because you're just timesing by identity matrix, so you're not changing anything, right? So if you do that, therefore you could say this the same thing as A, and then you could use that argument same to make that to become A. So that becomes A and A inverse. Now that they're right next to each other, now we can just say that's an identity matrix. Which happens to be identity matrix or 1. Doesn't matter how you want to put it, right? So, yeah, so that's that. Oh, another thing, I didn't do this, I didn't lose marks, but technically, if you have a function here, you should make it equal sign, right? I forgot about that. So it should be equal, and this is just a side note, so it's this. So maybe not arrow, it will be equal sign, right? So yeah, make sure it's continuous, right? It's like a function, right? So it's a function, so they should be equal to each other. Otherwise, I mean, who knows what I've done, right? So that's the idea. So either say it leads to identity matrix, or all the entries. Yeah, just put an identity matrix. I mean, we know it's 1, but just be careful with the technical terms, right? So that's that. The last one, which is not last one, sorry, I wish. Number 4, very similar to the question that the other test got, but we didn't really go much into it as they have. So I guess we got lucky there. But so again, so we have this expression AB equals to AC. And assuming that A is invertible, so this exists, right? This exists, right? So if that's the case, then prove it to me that B equals to C. And we've done that in 1.4, right? So how do we know that? Well, if A inverse exists, I'm just gonna do is, so what I'm gonna do is, I'm gonna put A inverse in front of everything. AB. You don't have to put brackets, as long as the order stays the same. That's all matters. Right? So I've done nothing different, right? A inverse, I typed it in the front, and I've done the same. Order matters, so make sure order is consistent, right? Don't shove it in between A, B, or AC. Then, you know, that will get you some penalty marks, I'd imagine. So if that's the case, then these two and these two will cancel, so it becomes identity matrix. And this is where I sort of did this. I mean, I just said, oh, they're both identity matrix, so just cancel it out, right? I don't lose marks for doing this, but technically you're not supposed to, because you can't really divide an identity matrix with another matrix, right? Or you can't actually just do any division through matrices, right? So you just say, I don't know, things like IB is same thing as B, IC is same thing as C, therefore B equals to C. So, you know, that would be a better way to go about it, right? No, nonetheless, if you do, just try not to cross. That's what they're saying, right? I didn't lose marks for it, so hopefully you don't either, but I mean, at least you know now, right? So, you know, like, why risk it, right? So, and the last question, oh no, no, I lied. It's not the last question. Second last question, number 5. Given I plus 2A inverse equals to 1, 3, negative 1, 2. Find A. Yeah, so again, it may be the exactly identical question. I know this is identical, I don't know about this one, but nonetheless, it doesn't matter, right? So we're just gonna inverse everything, because that way we can cancel out the inverse, right? I'm gonna same thing on the right side. So that inverse cancels out, so it's going to be I plus 2A equals 2. And what's the inverse of that? That's going to be 1 over determinant, right? Which happens to be AD minus BC, right? So we learned that in 1.3 or 4, remember? So AD, so 2 minus, oh, but there's a minus there, right? So that's going to be 3 minus, so they will become plus plus, right? Then it's going to be 2, 1 will flip, and the BC will just have the sign converted, right? So that's going to be 1, and that's going to be negative 3. Okay? So that's going to be 1 over 5. Now, what I'm going to do is now I'm going to move the I to the other side. So it's going to be, 2A equals 2, 1 over 5, 2, 1, negative 3, 1, minus I. And that I happens to be elementary matrix, right? So it's going to be, for 2 by 2 matrices, it's just going to be 1, 0, 0, 1. Right? So, and then divide the whole thing by 2 later, right? So one step at a time, right? So we're going to do this multiplication first. So that's, oh no, I'm running out of space. So it's going to be 2 over 5, negative 3 over 5. Yeah, barely, right? So it's going to be 1 over 5 and 1 over 5, right? And then I'm going to subtract it by matrices. So that's going to be 5 over 5 and 5 over 5 and 0, 0, right? Because 0 times whatever is 0, right? So if I do that, then I'm going to get, actually let's erase this part. Just so that you don't get confused, that's going to be 2A, right? So if we do this, then we're going back here. So that's going to equal 2. So 2 minus 5 is going to be negative 3 over 5. And then that's going to be negative 3 over 5 because we're just subtracting by 0. 1 over 5 stays the same because we're subtracting by 0. And then there's going to be negative 4 divided by 5. Okay, so that's what we have here. Okay, so then what we do is, so remember this was 2a, right? So now just get rid of the 2, divide by 2. Do not do this. Because again, you can't technically divide a matrix by an integer, right? So, put 1 over 2. I know it's trivial, but that's what you gotta do, right? So, can you guys see that? Yeah, 1 over 2. So if that's the case, then you just divide the whole thing again by 2. So that's going to be negative over 10. And it's going to be 1 over 10. And negative 4 over 10. Which we can reduce, negative 3 over 10. So if you wanted to reduce this, then you could say it's negative 3, 10. 1, 10. And that's going to be negative 2 over 5. And then that's going to be negative 3 over 10. Oh, in the bracket. And that will be your answer. Yep, that's what it is. Okay, so last question, and this really threw me off. Not because I didn't know how to do it, but I was constantly making stupid mistakes. Fortunately though, unlike the first question, I actually took some effort to check this because I knew 3 by 3. I'm not 100% confident with this, right? So the question is this. Given that A 266 and then you have 276 and 277. Give me the inverse using the inverse algorithm, which we learned at 1.5. For people in my class, I do apologize. I did not know the first quiz is going to also cover 1.5. But, hopefully you guys managed to do this because I was the only one who was clueless. Thank God I actually did 1.5, so because this had a lot of points. So anywho, so if you do that, so again, we follow the. So what we do is the inverse algorithm we talked about is gonna have identity matrix right next to it. Look at 1.5 if you're not sure what I'm doing. But anyways, so you have that. And then basically my goal is to make this identity matrix, and this will be, it will be changed, right? And that will be your inverse. So what I did was, so I subtracted row 2 and 3 using row 1. So that's going to be, so 266 is what I used. So I don't want to touch that. R1. And then they're all same 2s, right? So I just subtracted with the first row. So row 1 plus row 2 equals row 2, and plus row 3 gives me row 3, right? So if that's the case, all 2's disappear, which is a good sign. 6 is a negative, right? So that's going to be 1, 0, and that's going to be 1 and 1. Okay, now have to be careful about this part, right? So negative 1, so that's going to be negative 1. Nothing was changed, negative 1, 0, 1. Okay, so good. Okay, so that's what I did. The next part is I want to get rid of the 6's, right? So what do I need to do that? I use the third row to get rid of the 6's. So then I got 2, 0, 0. Have I touched the 10? I haven't really touched the middle one just yet. Negative 1, 1, 0. Negative 1, 0, 1. 1, 1. So I used these 1, 1 to get rid of 6, 6, right? So what I did was I did row 3 times 6 negative plus R1 gives me R1. So if that's the case, then that's going to be 0, that's going to be 0. This is a tricky part though, right? So negative 6, 6, so that's going to be 7. And then 0 is just 0. 6 negatives, so it's going to be that. Yes. Okay. So close. I got this part. We have this isolated. We gotta get rid of this guy, right? Because it's competition, right? So, okay. Running out of space. Okay. So if that's the case, then the next part is gonna be. Oh yeah. So I'm gonna eliminate this guy. So Come on. 2, 0, 0, 1, 0, 1, flunk, negative 1, 1, 0, 706. And then the last one I canceled out using the second row to get rid of its competitor. So it's going to be R2 minus plus R3 gives me R3. So that's going to be 0, and 0 times is 0, so it's going to be just 1. And then this is going to be the tricky part, right? So you have negative 2. Negative 1. Yeah. Negative 1, negative, so that's positive. Negative 1, so positive 1, negative 1 is going to give me 0. And then 1, negative 1, that's going to be negative 1. 0, okay, same thing, so it's going to be 1. Okay, so this, and make sure you don't just say this is it, right? Say A inverse is this matrix. Like insert in here, right? That's the idea. So that's good. But here's the thing, I didn't get that on my first try. So how do I make sure? Like how do I check, right? Well, remember what we learned, right? And a matrix times its inverse will always give you an identity matrix. So let's literally try to multiply, right? So it's gonna be, it doesn't really matter what order. I'll just show you what I did exactly. But again, it's the same idea. 2, 6, 6, 2, 7, 6, and then 2, 7, 7 times this inverse, right? Is 706, negative 1, 1, 0, 0, negative 1, 1. Oh, by the way, oh, no, sorry, I almost forgot, sorry, I did another thing, yeah, my bad. So what happened is there's 2 here, right? So I want to make this an identity matrix, right? So I divide the first row by 2. Can I just do it here? Yeah, let's do that here, whatever. R1, 1/2 is R1. You know, whatever. Technically you're not supposed to do it at the same... No, it doesn't matter, we can do it right now because R1 is not touched. So it doesn't implicate the other. Yeah, so it's going to be 1, it's going to be 2, and that's going to be 2. 6 divided by 2 is 3. So, very close. But anyways, so if I times these, which this is A inverse, right? This should give me identity matrix. And it does. I won't bother going into details. You guys should know how to do the multiplication by now. But anyways, yeah, so that really covers our first quiz. You know, I don't know how well we did, but yeah, I really should have got 100. Sorry, I'm being bitter because someone else from a different class got 100. But anyways, yeah, I mean, the principle-wise, nothing too difficult. So hopefully, we would do a lot better. You know, I'll try to make sure the video solutions are coming out steadily, but you know, make sure to do a lot of practices, right? And yeah, I mean, honestly, this is not rocket science yet, right? I mean, it might get harder later on. I hear linear algebra 2 can be a little brutal sometimes, but so is calculus 2. I remember taking that. It wasn't that difficult. Just a lot of tricks and techniques that you need to know. Oh, this is when I implement it, right? And this is when I execute it. But I mean, it's not like we're asking you to invent something new, right? So anyways, yeah, I think that's enough for this video, but hopefully this helps, and for new students who want a good practice round before they write the first quiz. So yeah, that's all there. I will see you in the section, I will see you guys again in section 1.5, 1.6, and so on, okay? So